Welcome back to another episode of Derivatives Examples. This is the 7th video, and this is where I run through 3 examples to show you how they're done. I make them either progressively harder, or I add techniques in that you may not know, or I show you things that you might have overlooked. So hopefully when you're doing examples like these or anything like this, you won't make mistakes and do them to the best that you can do them. On that note, these are the 3 examples. If you want to watch, you can. If you don't want to watch, by all means, click off. But I will start with number 1. Example 1. We have y equals x plus 1 over x squared to the power of square root of 7. Now this is just going to take the chain rule to solve, no biggie, but I'm going to rewrite this as x plus x to the power of negative 2 to the power of square root of 7. I only did this because we have 1 over x squared, that's the same as having x to the power of negative 2. I just want to keep it on the same level and not deal with fractions if I don't have to. Now we can start working out the derivative. When you do the chain rule, you do the derivative of the outside and leave the inside the same, and then multiply that by the derivative of the inside. Now what I'm going to do is do that. So the derivative of the outside would be bring the square root of 7 down, leave the inside the same, and then multiply to the power, take 1 off the power. So I'm going to have square root of 7 minus 1. Now I've seen some people, because when you see square roots in derivatives, it's usually you're square rooting the function. So when you take 1 off the power, they sometimes have the need to take 1 off the square root, because the square root of 7 is the same as saying 7 to the power of a half. Some people think that you need to take 1 off that power, so you're having 7 to the power of negative a half. But that's not it. You just take 1 off square root of 7. Because this is just a number, and there's no function in this, there's no need to take 1 off the power. It's just a number, so you're taking 1 off that number. I'm only leaving the take 1 on there because the square root of 7 is, I'm assuming, a long number, and I don't want to write the decimals for that. So I'm just going to have the minus 1, which is the exact same, which is correct. If you didn't have that problem, by all means, forget what I just said, but some people have a problem with square roots and derivatives, and I just wanted to clarify that. Now, we multiply by the derivative of the inside. Now, the derivative of the inside, derivative of x, is 1, plus the derivative of x to the power of negative 2. Now, power rule, you bring the power down, and then you take 1 off the power. Negative 2 take 1 is negative 3. Okay, so we're going to simplify this. Square root of 7, bracket, x plus, I'm going to bring this back to its original form. Square root of 7, take 1, multiplied by 1, minus, because we have, this is multiplied onto a negative 1, we will replace the addition with the subtraction sign, and it will be 1 over x to the power of 3, because just like here, where I put the x to the power of negative 2 back to 1 over x squared, we have x to the power of negative 3, so I'm bringing it back to 1 over x cubed. Now I'm going to rewrite this. I'm going to put the bracket on first, but I'm going to rewrite this, and I'm going to show you why I rewrote it that way. Okay, now why did I rewrite it this way? Why did I just switch these around? Which is what I did. Why did I switch them around? Now, when you have to the power of something like this, it sort of carries on a bit of space, as you can see. Now, when you're simplifying it, you want to make it compact. You don't want to make it incorrect, but you want to make it like, confined, small, simple, simplified. So I left this out the front because this is the number. You usually leave a number out the front if you've got one. Now I left this here because it hasn't got a long power like this has. So it's small. And this, I left this out here because the power is long. When you have a long power and it's on the back, it looks more simplified than this, because it's bigger on the inside. But if you have it bigger on the outside, it just looks like a tail, whereas here the whole thing looks bigger. All you need to know really is that when you have it to the power of something, you want to sort of leave that on the back end like this. Okay, I'm going to do a second example. Second example is y equals x to the power of 4 minus 1 over x to the power of 4 plus 1. I'm going to use the product rule to solve this. I did this in the previous episode. So I'm going to have to bring them as a function multiplied by a function. The only way I can do that is if I bring this up to the top. So x to the power of 4 minus 1 is now multiplied to x to the power of 4 plus 1 to the power of negative 1. I had to make it to the power of a negative 1 because I wanted to bring it up and turn it into multiplication instead of division. Now that we've got it like this, we can solve for the derivative. Now the derivative is u dash v plus u v dash, which is the product rule. Now we have a function multiplied by a function. So we're going to call this one u and we're going to call this one v. The derivative of u, if u is x to the power of 4 take 1, the derivative is 4x to the power of 3, because we bring the power down and take 1 off the original power. We don't need to add the 1 because when you derive negative 1 you get 0. Now we're going to multiply this to v. This is v here, so we're just going to leave it as the same. X to the power of 4 plus 1 to the power of negative 1. Now we add u, which is x to the power of 4 take 1, and then we multiply it to the derivative of v. Now this is the chain rule, so we're going to need the chain rule to solve the derivative of this little function here. I'm going to grab a separate sheet of paper and rewrite it. So it is v is equal to x to the power of 4 plus 1 to the power of negative 1. What's the derivative when you follow the chain rule? You derive the outside, leave the inside the same, and then you multiply it to the derivative of the inside. The derivative of the outside, you bring the power down, negative 1, you multiply it to the inside, which is the same, which stays the same, and then you take 1 off the power. Negative 1, take 1, is negative 2. And then we multiply it to the derivative of the inside. The derivative of x to the power of 4 plus 1 is 4x to the power of 3, because just like before, you derive this, bring the power down, take 1 off, and derivative of 1 is nothing. So now we're left with this. We can rearrange it and bring the 4x to the power of 3 out the front. Well, because there's a negative 1 here, we'll multiply the negative 1 onto that as well. And what we're left with is this. Now I'm going to simplify it here, just so it looks a little neater, and we can probably fit it in. So we're going to have negative 4x to the power of 3 over x to the power of 4 plus 1 squared. Because this is to the power of a negative 2, so I'm bringing it down to make the power a positive. Now we have what we need to complete this, because we need a derivative of v, and we have a derivative of v. So we're going to input this over here. So we're going to multiply by negative 4x to the power of 3 over x to the power of 4 plus 1 all squared. Okay. Now that we have this, we can do a bit of simplifying and rearranging to make it look neater and better represented. This is to the power of negative 1, so I'm going to bring it down, and we'll have 4x to the power of 3 over x to the power of 4 plus 1. Now, I don't have to write to the power of 1 because it's already... I will, actually, because we will need it, and I don't want you to get confused. So I'm bringing it down and making the power positive, and we're adding it to... Hold on, we're multiplying by a negative, so I'll put the negative. Subtract 4x to the power of 3 over x to the power of 4 plus 1 squared, and I'm going to multiply this into the fraction. So we'll end up with this. Now I hope this didn't confuse you. All I did was just multiply these together. Because this is essentially over 1, when I multiply it to this, I'm going to multiply it onto the top, just like I did there. And because this is a negative, I'm multiplying a negative by a positive, we get a negative. Okay, so now we've got this. Most people will let you leave it like this. You don't have to do it any further. And if you want to watch the next example, skip to it. But I'm going to do this example and simplify it. Now, here we have an x to the power of 4 plus 1 squared. We have an x to the power of 4 plus 1 to the power of 1. If we want these two to have the same denominator, what we're going to have to do is multiply the bottom and the top of this side by x to the power of 4 plus 1. I'll show you what that looks like. If we multiply this side by x to the power of 4 plus 1, we get x to the power, we get 4 multiplied by x to the power of 3 multiplied by x to the power of 4 plus 1. We've multiplied the top by this, and now we're going to multiply the bottom. X to the power of 4 plus 1 squared. I only did this because if I'm multiplying x to the power of 4 plus 1 by x to the power of 4 plus 1, they're the same, so it's squared. You can write it as being squared. Minus, we'll write this top bit, and the bottom. Now here's the funny bit. Now they look the exact same, because they are the exact same. And because they're the exact same, we can bring these two fractions together. What does that look like? It looks like this. 4 times x to the power of 3 multiplied by x to the power of 4 plus 1. Subtract 4x to the power of 3 multiplied by x to the power of 4, subtract 1, all over x to the power of 4 plus 1 squared. This is the exact same as this. Don't get too confused if you are or hung up on it. Because I made the denominators both the same, I can essentially merge it together and put the subtraction up here, which is what I did. I merged them together. Okay. Now that we've got this, what we're going to do is expand the brackets. And I know this doesn't seem like simplifying, but the end result is simplified further than if we left it as this. Okay, so if we expanded it out, 4x to the power of 3 multiplied by x to the power of 4 is 4x. 4x to the power of 7 because you add the powers, plus x to the power of 3, 4x to the power of 3 plus 1, multiplied by 1 is just 4x to the power of 3. Subtract 4x to the power of 3 multiplied by x to the power of 4, same as here, 4x to the power of 7, and negative 4x to the power of 3 multiplied by negative 1 is plus 4x to the power of 3. All over this x to the power of 4 plus 1 to the power of 2. Now we're going to use the process of elimination. We have a positive 4x to the power of 7 and a negative 4x to the power of 7. They can go. Now we're left with a positive 4x to the power of 3 and then another positive 4x to the power of 3. We're going to add these together and get 8x to the power of 3 all over x to the power of 4 plus 1 squared. And that is much more simplified than this. Even though this is probably good enough, this is more simplified. Okay. And that is the derivative of x to the power of 4 minus 1 over x to the power of 4 plus 1. Now I'm going to finish with the third example. Y equals the fifth root of x multiplied by tan x. Just like how when we have a square root, that's the same, essentially. When you have a square root, it's the same as having a 2 instead of a 5. You just don't write the 2. So just like if you had a square root, you would have it to the power of a half. Now it's all of this is to the power of a fifth. So it can be written like this. See that? With the square root, you have to the power of 1 over 2. When you have a cube root, when you have a 3 here, you have to the power of 1 over 3, but we have a 5, so it's to the power of 1 over 5. Now we use the chain rule to solve this. The chain rule consists of deriving the outside and leaving the inside the same, then multiplying by the derivative of the inside. So derivative of the outside, we bring the power down, we leave the inside the same, and then we take 1 off the power. Now when you take 1 from 1 over 5, you get negative 4 over 5. Okay, do it on the calculator if you don't believe me, but that's it. 1 over 5, take 1 is negative 4 over 5. And now we multiply by the derivative of the inside. Now the derivative of the inside, since we have two functions and they're multiplied together, it's going to use the product rule. The product rule is u dash v plus u v dash. If we consider x to be u, and we consider tan x to be v, that makes it a lot easier, because we know what we're going to do now. Okay, I'm going to rewrite this and give myself a bit more room. 1 over 5 multiplied by x tan x to the power of negative 4 over 5. Now we're going to do the product rule, because I'm multiplying by the derivative of the inside. Okay, so if we've labelled u as x, the derivative of u is 1. So we're not going to bother writing it, because it's just 1. And then we're multiplying that onto v. If v is tan x, 1 multiplied by tan x is tan x. Plus u, which is x, multiplied by derivative of v. If tan x is v, the derivative of tan x is sec squared x. So that is, some people might say good enough. I'm going to go a bit further because I always like to simplify if I can. It makes things look neater, and I'm all about neatness sometimes. Okay, so what are we going to do here? This here is to the power of a negative 4 over 5, and this is to the power of a positive 1. The positive 1 is invisible. So we're going to put this on top of the fraction and this on the bottom. Here's the fraction, because this is multiplied to this, and this is also multiplied to this. So this will be the fraction we're using. 10 x plus x multiplied by sec squared x multiplied by 1 is just 10 x plus x sec squared x over, now we have 5, because the 5 is being multiplied onto whatever's on the bottom, and whatever's on the bottom is this, x tan x to the power of 4 over 5, because when you bring something to the bottom and the power is a negative, it becomes a positive when it comes to the bottom. I'm going to leave it like this. This looks simplified enough to me. And that there is the derivative of the fifth root of x multiplied by tan x. Thanks for watching. I hope you learnt something.